This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A cubic yard of soil is not one fixed job site quantity. The number only makes sense when I know whether that yard is still in the ground, loose in a truck, or compacted in the fill. That distinction is the heart of earthwork estimating. If I compare quantities from different states as though they were equal, the error turns into extra truckloads, missing fill, schedule trouble, or all three. Think about one ordinary piece of ground before the bucket touches it. Its particles are sitting together in their natural arrangement. Excavation breaks that arrangement and introduces more air between the pieces, so the same soil occupies more space. Placement and mechanical compaction then reduce the void space, so its volume goes down again. The soil did not magically gain or lose solid particles. Its bulk volume changed because the spacing between those particles changed. I put the three volume states side by side because the names carry the estimating logic. Bank material is undisturbed material in place. Its quantity is expressed in bank cubic yards. A cut quantity taken from existing grades starts on that bank basis because the soil has not yet been excavated. Loose material has been dug, loaded, or stockpiled. Its quantity is expressed in loose cubic yards. This is the state that occupies space in a dump body or a soil pile. When I estimate haul-off, I need the loose quantity because the truck receives excavated material, not an untouched block measured in the ground. Compacted material has been placed and mechanically densified. Its quantity is expressed in compacted cubic yards. A required finished pad or backfill quantity is normally about the volume after placement and compaction, subject to the plans, specifications, and project geotechnical requirements. Here's the simple memory connection. Bank is before the bucket. Loose is after the bucket. Compacted is after the roller. Before the bucket, after the roller. If I keep that order clear, the rest of the math has somewhere solid to stand. The common mistake is a one-to-one assumption. A contractor sees a cut quantity and treats that same number as truck volume. Then the contractor sees a fill quantity and orders that same number as loose delivered dirt. Both moves ignore a change of state. The unit still says cubic yards, but the basis is different. It is like comparing gross price with net price without noticing the label. The numbers look compatible while the missing definition creates the problem. Swell is the increase in bulk volume that occurs when bank material is excavated and becomes loose. The excavator breaks the in-place structure apart. More air sits between the clods or grains, so the pile occupies more space than the same material occupied in the cut. I want to separate excavation swell from another use of the word swell. In earthwork estimating, swell usually means the bank-to-loose volume increase caused by excavation. In foundation discussions, someone may use swell to describe moisture-related expansion in reactive soil. Those are not interchangeable ideas. This lesson is about the estimating change caused by digging and loosening the material. The conversion factor must come from reliable project information. Soil type, moisture, excavation method, and actual material condition can affect the result. I would not take a percentage attached to a generic soil name and present it as a universal California rule. The estimating principle is dependable, but the factor is project specific. Suppose a hypothetical project has 1,000 bank cubic yards of cut, and reliable project information supports a 30% bank-to-loose swell factor. 30% of 1,000 is 300. The excavated quantity is therefore 1,300 loose cubic yards. If the actual allowable truck volume for that operation is 10 loose cubic yards per load, the volume estimate is 130 loads, not 100. That extra 30 loads is the consequence of changing the basis correctly. If the bid carried only 100 loads, the excavation did not create the estimating error. The error was already in the bid because bank volume was matched directly to loose truck capacity. Truck planning still has to follow the real operating limits of the equipment and hauling arrangement. A volume calculation is not permission to overload a vehicle. The point here is narrower. Whatever allowable capacity governs the load, I match it to loose material because loose material is what enters the truck. Shrinkage describes the reduction in volume as soil is placed and compacted. Loose fill contains void space. Mechanical compaction, together with the moisture conditioning and procedures established for the project, rearranges the particles and reduces that space. The finished compacted volume is therefore less than the loose delivered volume in the ordinary estimating relationship described here. Imagine a pad that requires 850 compacted cubic yards. Project-specific information shows that 1,000 loose cubic yards of the approved material will yield 850 compacted cubic yards under the required placement and compaction process. Ordering only 850 loose cubic yards would leave the pad short. The contractor needs the conversion from delivered loose volume to finished compacted yield before fixing the import quantity. Notice the direction of the calculation. For export, I start with bank cut and convert it upward to loose haul volume when swell applies. For imported fill, I start with the required compacted result and work backward to the loose quantity that must arrive. One problem asks how large the dirt becomes after excavation. The other asks how much loose dirt is needed to produce the compacted result. The word shrinkage can also create a quiet estimating trap, because a stated percentage is meaningless unless its reference basis is clear. Is the reduction measured from loose material to compacted material, or from bank material to compacted material? I do not guess. I identify the basis used by the project information and keep that basis consistent through the conversion. Relative compaction requirements also belong to the site-specific plans, specifications, and geotechnical criteria. I would not teach 1% as a universal rule for every California building pad. The general B supervision lesson is to recognize that required compaction affects yield, inspection readiness, equipment planning, and the final quantity. The engineer or project documents establish the target and testing requirements for that site. Cut means removing soil from a high area or excavation. Fill means placing soil to raise or shape an area. Import means bringing needed material onto the site. Export means hauling excess or unsuitable material away. Stockpiling means holding material temporarily for later handling. A balanced site has enough suitable excavated material after the proper quantity conversion to satisfy the required compacted fill without planned net import or export. The phrase "after the proper quantity conversion" does most of the work in that sentence. Bank cut cannot be compared directly with compacted fill merely because both numbers use cubic yards. The practical sequence is straightforward. I identify the cut on its stated basis. I identify the required fill on its stated basis. I apply the supported project conversion factors so the comparison uses a common basis. I confirm that the excavated material is suitable and approved for the intended fill. Only then can I decide whether the site has an excess, a deficit, or a workable balance. If adjusted usable cut exceeds required compacted fill, the project may need export or another approved on-site use. If required compacted fill exceeds adjusted usable cut, the project needs import. If the adjusted quantities match and the material is suitable, the project may be balanced. A mathematically equal pile is not useful balance if the material cannot be used where the fill is required. Consider a hypothetical estimator who subtracts a compacted fill number directly from a bank cut number. The subtraction is easy, but the answer is not yet meaningful. Converting to a common basis may reverse the apparent surplus or expose a shortage. Good earthwork estimating is not difficult because subtraction is difficult. It is difficult because every quantity must carry its condition with it. Hauling is where the quantity decision becomes a schedule and cost decision. The loose cubic yards affect the number of loads. The haul arrangement affects cycle time. Loading, travel, unloading, and return all consume time. Disposal or placement requirements affect where the material can go. A missed swell conversion can therefore multiply through trucking cost, equipment standby, labor coordination, and the duration of the excavation phase. Stockpiling can reduce immediate hauling or preserve usable soil for later fill, but it does not erase handling cost. Material may be loaded, moved, protected, and then loaded again. The stockpile also needs a location that does not interfere with access, excavation safety, drainage controls, or later work. Saving soil on site makes sense only when the material is usable and the project can manage it safely. Loadability describes how readily material can be excavated and loaded. Traffic ability describes whether the ground can support the movement of trucks and heavy equipment under the actual moisture and drainage conditions. These ideas affect production, but they do not justify inventing a universal rate. A contractor should base production and equipment assumptions on the material and site information available for the project. This connects quantity planning to sequencing. If a stockpile blocks the haul route, if wet ground cannot support the planned truck movement, or if imported fill arrives before there is a protected place to put it, the arithmetic may be correct while the operation still fails. Quantity, access, drainage, and timing have to agree. The first safety control happens before excavation begins. California requirements call for notification to the Regional Underground Utility Notification Center at least 2 working days before the start of excavation. 2 working days is not automatically the same as 48 ordinary clock hours because weekends and holidays affect the count. The field supervisor should treat utility coordination as a scheduled prerequisite, not a phone call made when the excavator is already idling. At the excavation edge, employees must be protected from spoil, materials, or equipment that could fall or roll into the excavation. The cited California rule provides a basic method. Keep those hazards at least 2 feet from the edge. Use retaining devices sufficient to prevent them from entering, or use both as conditions require. The physical consequence is easy to understand without inventing a story about code intent. Fresh spoil placed on the lip adds weight beside an unconfined excavation face. It can also fall or roll directly onto people below. Moving the pile back or retaining it addresses the hazard created at the edge. When mobile equipment operates beside an excavation or approaches an edge and the operator does not have a clear and direct view, a warning system is required. The source-backed examples include barricades, hand signals, and stop logs. The supervisor must select and maintain a control that fits the operation rather than relying on the operator to judge an unseen edge. For a trench excavation 4 feet or more in depth, a stairway, ladder, ramp, or other safe means of egress must be arranged so an employee does not travel more than 25 feet laterally. Employees also may not work in an excavation where water is accumulating unless adequate precautions are in place. Those precautions depend on the condition and may involve protective systems, controlled removal, monitoring, or other measures identified by the governing requirements. These controls affect the earthwork plan itself. A spoil setback consumes room. Safe egress needs a reachable location. Warning systems affect equipment movement. Water control affects whether work may proceed. Safety is therefore not a note added after the quantity takeoff. It changes how the site can actually be used. Loose soil is also an environmental management issue. On work covered by California's Construction General Permit and the applicable site requirements, erodible stockpile materials must be contained and protected from wind and precipitation. The research for this lesson identifies covering at the end of each business day and during precipitation events as a required stockpile control. That daily timing matters. A pile left on Friday is still a project condition on Saturday. Waiting until rain starts can be too late to install a stable cover safely and effectively. The supervisor should plan the cover, anchorage, perimeter control, inspection, and maintenance while the crew and materials are available. Upgradient run-on water also needs to be diverted away from exposed soil or conveyed through the site using an appropriate controlled method under the applicable permit requirements. The supported effect is practical. Keeping clean run-on away from loose soil reduces contact that can mobilize sediment. I do not need to claim a hidden regulatory motive to understand the field consequence. Picture a hypothetical crew that calculates every truckload correctly, then leaves the exported soil staging pile unprotected. The quantity estimate may be excellent, but site supervision is incomplete. Dirt has to be managed through its whole job site life, from notification before the first cut to safe placement, temporary storage, hauling, compaction, and environmental protection. Here's the complete memory check. Bank is soil before the bucket. Loose is soil after the bucket and in the truck. Compacted is soil after placement and the roller. Swell converts bank material toward loose haul volume. Shrinkage or compacted yield connects loose delivered material to finished fill. Cut removes, fill places, export leaves, import arrives, and balance is judged only after the quantities share a basis and the material is suitable. For supervision, I also remember the supporting controls. Utility notification comes at least 2 working days before excavation. Spoil, materials, and equipment that can enter the excavation need the 2-foot setback, adequate retention, or both. Required egress, equipment edge warnings, water precautions, and applicable stockpile protections must be built into the operation. There is an audio practice quiz for this specific episode covering cut, fill, swell, shrinkage, hauling, and the field controls I just explained. It is audio-based. The questions are read aloud and you answer by tapping, because I know you may be studying while driving, working, or otherwise on the go. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. If you have any questions about this material, comment below and I will help you work through them. Subscribe so I can help you stay on track through every episode until you get your license.